Hey guys, we shall take up one more problem on convolution integral. This time the problem statement is evaluate y of t is equal to u of t plus 1 convolved with u of t minus 2. Fine. So solution. So this is of the form what? Y of t is equal to x of t convolved with h of t, right? So we'll assume that x of t is equal to not assume, we'll assign x of t is equal to this one u of t plus 1, and we assume that we assign that h of t is equal to u of t minus 2, right? So we got our x of t and h of t. So step 1, what is the step 1? So plot x of t and h of t. So x of t is unit step function shifted left one time. So x of t is something like this. So this is 0, this is minus 1. Unit step function shifted left one time, right? What about h of t? H of t is unit step function shifted right two time. So t, this is 1, this is 2, 1. Correct, no? Yes. What is the next thing? So I have to bring this to tau. I have to bring the independent variable in the form of tau, right? So what I have to do is I have to get x of tau. It's nothing but just change the independent variable. 0. Sorry, this is minus 1. Same as this figure, but change the independent variable. Okay, this is tau. This is 0. How do we get h of minus tau? The mirror image of h of t, right? So this is minus 2, minus 3, dot dot dot. So this is the mirror image. So it started from 2. This will start from minus 2. This goes till minus infinity, and this is tau. Right? Okay. So what is the next step? Next step is to bring both the signal in a single independent variable, which is tau. Right? So step 2, you have to bring both the signal in a same independent variable tau. Okay. So what was x of tau? It was started from minus 1, and you just put h of minus tau just before x of tau. Okay. So this is x of tau. So we have h of minus tau, which started from minus 2, right? We just keep h of minus tau just before x of tau, and controlling slider is this. Slider index is what? Depends upon where is this. This is at minus 2, right? This point is minus 2. Therefore, so controlling index is t minus 2, right? Fine. Now, if I move this h of minus tau from minus infinity till just before minus 1, there is no overlap, right? So there, in that case, what is the output? Output is 0. Correct now? So for t minus 2, this slider t minus 2 slider less than minus 1, less than minus 1, right? Now I have to write it in terms of t. Minus 2 goes to the other side. T is less than minus 1 plus 2 is 1, right? So what is the output y of t? Y of t is equal to 0. Why it is 0? Since there is no overlap. Okay. So next is we have to move this signal h of minus tau further right. So far we have took t minus 2 less than minus 1, in the sense t minus 2 from minus infinity till just before minus 1. Now I need to move it further right. So t minus 2 is greater than or equal to minus 1. So this is minus 1, this is x of tau, this is tau. Now I'll move this h of minus tau further right. So I keep it here. This is t minus 2. So therefore the overlap region start from minus 1, right, and ends at depending upon where I keep this t minus 2 slider, right? So what is the condition for t minus 2 So this t minus 2 is greater than or equal to, right? Because I excluded 1 here. Here it is greater than or equal to 1. Here I have to include that one. So I have to write this in terms of t. So t is greater than or equal to 1. Sorry, this is t minus 2 is greater than or equal to minus 1. So therefore t is greater than or equal to 1. What is y of t? So y of t is integrating from minus infinity to infinity x of tau h of t minus tau d tau. So y of t is equal to integrating from the integration range is starting of the overlap region and end of the overlap region, right? Minus 1 starts overlaps at minus 1 and ends at depending upon where I keep this side at t minus 2. What is x of tau? Amplitude is 1. What is h of minus tau? This is actually h of minus tau, right? What is this amplitude? This is also 1. Since both are unit step function, both the amplitude are 1. So left out with d tau, right? So now integration differentiation cancels out. So y of t is equal to, I end up with tau with the integration limit minus 1 to t minus 2. Okay. So this is equal to what? Upper limit t minus 2. If I apply the limit here, upper limit minus lower limit, upper limit is t minus 2, minus of lower limit is minus 1. This is nothing but t minus 2 plus 1, which is equal to t minus 1. Right? Fine. So therefore, I'll write it here. Therefore, what is the combined output? Y of t is equal to 0. It is 0 for t less than 1, and it is equal to t minus 1 for t greater than or equal to 1. This is the output from the LTI system.